Hey everybody! Today I'm going to be talking about the Brazil nut effect, or its other name, granular convection. So first, what is Brazil nut effect? It is a phenomenon where the largest particles end up on the surface of a granular material containing a mixture of various sized objects. The name Brazil nut comes from the example of a typical container of mixed nuts, where the largest would be Brazil nuts. So then, when they shook it, the largest nuts would be on top, which would be the Brazil nuts. So now that we know what Brazil nut effect is, how does it work? Most people would think that at the largest objects would sink to the bottom of every single container, like water, because that's basic understanding of gravity. So to explain this, there actually are a lot of explanations for this. So to understand, we need to know what convection is. Convection is the movement of small particles. This term is usually used for gases and liquids, but uh, future studies also show that it could be used for solids as well, and it's called granular convection. So in the drawing above, we could see granular convection working. So when you do vertical shaking, it causes vertical vibrations, which causes the particles to move more and more freely. This allows the large object to rise to the top, and as it rises to the top, it leaves spaces where the smaller particles on the top and the sides move in to fill in that small area. And this continues on and on and on until the large object is on top. Now, when it's on top, it's too large to fit back down to small spaces. So all I can do is stay on top and move side to side, while the smaller particles on the bottom continue to fill in gaps and spaces in a continuous circle. So another aspect of this is the center of mass before the shaking. The center mass of the whole system in a random state is it's not low. It could be higher due to the more empty spaces around the larger Brazil nuts than around the smaller nuts. When the nuts are shaken, the system has a tendency to move to a lower energy state, which means moving the center of mass down by moving the smaller nuts down as well, and thereby moving the Brazil nuts up. The whole system acts in a highly non-monotonic fashion. This means that large particles that are either very heavy or very light move faster towards the surface of a granular mixture than particles of intermediate weight. Air, air pressure also has a part in the Brazil nut effect. So when they did an experiment where when they put the system of mixed nuts in a vacuum, the time for the large particles to rise to the top took longer by about 10% of the time it takes in regular air pressure. So this means that uh, the gas moving back and forth through the spaces between the grains is very important in the phenomenon. So there's probably a so in my research, I've seen that particle size, particle density, and air pressure all play a role in the Brazil nut effect. However, they tested with density, and they found out that if an object of that's large but has less density than the surrounding smaller particles are shaken in a vertical fashion, the large object still rises to the top. When it's the same size but more dense, it still rises to the top. So therefore, density couldn't really play a part in this. So sadly, we there still has not been a fully acknowledged answer to why the Brazil nut effect is happening this way. People has used friction, such as the friction on the side of the container, to contribute to the rise of the larger particle. People have contributed to the convection currents, whereas the particles stay at the top. It can't go down anymore because it's too large for the to float back down the convection currents. Now, applications. It is used in manufacturing and geology. In manufacturing, it's actually difficult to manufacture mixed nuts, cereals, trail mix, because along the way to from the conveyor belt to packaging, there's a lot of shaking, and this could cause segregations of food, where larger food particles are on top and smaller food particles are on bottom. So basically, your Lucky Charms will have plain cereal on the top and all the marshmallows are on the bottom, and that's just a bad day. So to solve this, they pour the larger pieces in first, and then they put in the smaller pieces in finale. So then, along the way, it's gonna be distributed correctly. But this only works in rectangular and cylindrical boxes. When it's packaged in a, I don't know why, cone, it's actually a reverse of the Brazilian nut effect. So basically, the smaller pieces would stay on top and the larger pieces will stay on the bottom. Now, the Brazil nut effect is also seen in geology, where in nature near glacial areas, there's this thing called a freeze-thaw cycle, where after geologists pick stones from the ground, it leaves pits in the ground. So then underground water flows in there, and during winter it freezes. When it freezes, it lifts all the particles above it. So then when spring comes, as the water starts to melt, and the smaller particles settle down at the bottom. However, the larger particles pertaining to the Brazilian nut effect stays on top, and this is useful because then geologists could find new stones and boulders and rocks that can be found without excavating all the time. So that concludes my explanation for the Brazilian nut effect. I know I've been saying nut like a lot of times, and it must be driving a lot of you pretty nutty. But I actually did an experiment to test this out because I didn't believe in this, and it proved me wrong. So I would suggest you guys do this as well because it's actually pretty cool, and enjoy.